Hello, welcome once again to the Sun Devil Learning Labs through Arizona University. My name is Michael Barker, and today we're going to be talking about adding fractions with our fifth graders. Wednesday, we always have a word problem Wednesday in our fifth grade math program, and today we want to work on adding fractions with unlike denominators. And before we start, I think we'll review that objective. We want to solve word problems that require adding fractions with a sum between 1 and 2. We're not going to be doing multiples and getting into something that shows totals of 17 or any big numbers like that now. We're just going to work on fractions that give us a sum between 1 and 2. So we want to keep that in mind as well. So it's important now that when we get set, I always have my little prerequisites here for us. Let me move my picture first. We'll move that just out of the way a little bit. You can see this image in the notepad. If you see this notepad here, that means it's kind of important and it might not be a good idea. Pause the video and make sure you write these things down. The next thing you need to do is make sure that you're in a comfortable setting with no distractions. That's our first rule all the time. Make sure you don't have a little brother or sister running in, or the TV's on in the next room, or anything that can keep you. You need to be working in an area where you can focus on the lesson. Otherwise, it's just going to take you a lot longer to finish the lesson. If you have to talk with your parents and find a quiet place where you can work, or maybe they can make sure that you're not having to deal with outside resources. Next, I want you to gather any supplies you might need today. I suggest a couple of pencils, an eraser maybe, a notebook, or at least several sheets of paper, but I hope you're keeping a notebook with some of this information in it. Paper, scissors maybe, if you feel like you want to use some fraction bars, or hopefully you're maybe just working on paper now and be able to draw your illustrations. A ruler is definitely helpful. You can be precise in marking out your area models, or just it helps for drawing straight lines. Finally, be sure and use the restroom before we start. And remember, you can always pause the video if you need to take a break. Word Problem Wednesday. We have a format that we've been trying to use, and basically you'll see a template like this sometimes where we'll introduce the problem, but cubes is the fundamental of what we're working with here. We want to talk about C-U-B-E-S. Each letter obviously stands for something. C, it says circle, key numbers. What do I know? What are the numbers in the question that I already know? What can I determine that we know is true and I'm not being asked to figure out? Because that's where you comes in. You underline the question. That's what am I being asked to solve? I'm trying to move our picture here again. So you can see, underline the question. What am I being asked to solve? And then we get to B, we want a box. We'll draw a box around math actions. Are we being asked to add, subtract, divide, multiply, or something else? And sometimes they may not be these exact words. They may say, what are they if they're combined? Or if you put two things together, what is the total? Sometimes our math action words, we're going to have to count on our reading ability a little bit and interpret things. Then we want to evaluate. What steps do I take? How am I going to solve the problem? And what information don't I need? A lot of times there might be useless information that really doesn't have anything to do with us solving the problem. They may be part of a story, but they really don't involve the math in our problem. And then finally, S, we're going to solve. We'll solve and we'll check our work and ask ourselves if our answer makes sense. Sometimes we'll come up with some ridiculous numbers that we know just can't possibly be accurate. So let's start Word Problem Wednesday for this week. And we'll start with this word problem. Penny uses 2/5 of a pound of flour to bake a vanilla cake. She uses another 3/4 of a pound of flour to make a chocolate cake. How much flour did she use all together? Okay, we've got our template, and I think if we move to our first part of the solution, we can see we'll just follow right here. We're going to circle key numbers. So numbers may not always be written by a number either. That's part of reading a word problem. But here, she used 2/5 of a pound. So 2/5 is 2 parts of 5. We know that as a fraction. We can write it here. That's one of our key numbers. She used another 3/4 of a pound. So we can write 3/4, 3 parts of 4 to flour to make chocolate cake. I don't know if we'll find any more key numbers, but then we have to underline what is the question? What are we being asked? And the question here, and I've underlined it for you, is how much flour did she use all together? All together is our hint that's going to tell us that they want a total or a sum, which means we're going to have to add. So I will add down here, we're going to add our 2/5 and our 3/4. Well, we're going to want to do a little bit of evaluating. Does it matter if she's making a vanilla cake or a chocolate cake? It really won't matter because the only question we're being asked is how much flour is being used altogether. So that really is useless information in our story, and it's just something that we can ignore. So our next step will be we'll work on solving it, and we've wrote our fractions, our 2/5 and 3/4, and we want to draw our area models. We want to take one unit, one whole unit, and we're going to break it up into 5 equal parts. 1, 2, 3, 4, 5, and we're going to shade those parts. 2 of them, we'll just shade 2 of them, 1 and 2, because that's 2 out of 5 whole. And then we have our other whole, we'll break into 4 equal parts, and we're going to shade 3 of those, 1, 2, 3, because we have a total of 3 out of 4 parts. Okay, so let's look at this now, and we will work with our area model a little bit because it's pretty obvious that our 2/5 and our 3/4 weren't something that we could add because they weren't cut up into parts of the same whole. And what we have to do is find multiples of our denominators, 5 and 4, that basically something we can multiply and wind up with the same denominator, the same number of parts that we can cut each of our area models into. In this case, the first common multiple we're going to come up with is if we multiply 4 times 5 is 20. And that really would be, because 4 would be 4, 8, 12, 16, 20, and 5 would be 5, 10, 15, 20, and that's where they would meet. So we cut both parts of our models. Both of our models now become grids, or there's going to be 20 boxes. 2/5 is still shaded, which is going to be 1, 2, 3, 4, 5, 6, 7, 8 boxes. And on the other side, 3/4 is going to still be shaded, and that's going to be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boxes. Our area models haven't changed. We've just broken them into smaller parts. And you'll see that here now, where I've now developed our fractions. We have 8 parts out of 20 plus 15 parts out of 20 is going to give us a total of 23 parts out of 20. These 23 parts out of 20 can then be thought of as a mixed number. If we take 23 20ths, that becomes 1 and 3/20. We know that there's 20 whole squares in a unit, in our whole unit, so that leaves us with 3 left for our mixed number, the rest of our fraction. So the total amount is 1 and 3/20, And then we have to finally, we're going to have to express that answer in writing. We write a sentence. Usually when you have a word problem, we should write our answer in the form of a sentence because it's just the nature of the question. If the question's a sentence, then we should answer with a sentence. And so quite simply, Penny has used 1 3/20 pounds of flour. Okay, now that we've been through our first model, it's time for you to work on one. I'll give you a word problem, and then we'll see how you do with using our cubes method. First, it says Carlos would like to practice the piano 2 hours each day. So today he practiced the piano for 3/4 of an hour before school and 7/10 of an hour when he gets home. How many hours has Carlos practiced piano? And how much longer does he need to practice before going to bed in order to meet his goal? I'm going to give you about 10 minutes, and then we'll come back and work on it. Remember, follow your template, circle the key numbers first, underline the question, box any math action words you can figure out, and then we'll evaluate, solve, and check. And hi, this is what the first part of your problem should have looked like. We want to circle our key numbers. How many key numbers did we have? 2 hours each day is going to be important. That's the total. How many hours has he practiced already? Well, he's practiced 3/4 of an hour before school and 7/10 of an hour when he got home. So we know those key numbers, and we circled them all. I used blue to kind of help keep our circles and squares and everything a little bit separate. You don't have to use different colors, but sometimes it's just as easy. We're going to underline the question. And actually, we're going to find out there may be 2 questions in this word problem. How many hours has Carlos practiced piano? And then the second question, how much longer does he need to practice before going to bed in order to meet his goal? And you'll notice that we've got a red square around longer. We've now looked for our math action, and we've boxed longer because we're going to have to figure out how much time he has left. And we also have an and question because we know we're going to add during our problem. So we're going to work on a couple of different steps to answer both questions. Let's look at an area model first. We know we can draw the numbers that we already know. We found our key numbers, 3/4 and 7/10. 3/4, we draw a model, something that looks like this. Yours could be a little bit different. I shaded mine in blue. 1, 2, 3 out of 4 parts. And 7/10, 1, 2, 3, 4, 5, 6, 7 out of 10 parts. The next step on your sheet should have looked something like this. You got to figure out exactly how many parts you're going to break your sheet into and your area model into so that you have the same number of parts in each. So here, if we only had 4 parts, we know that 4 times 5 will give us 20 parts. And here we had 10 parts already. So we only had to multiply by 2 to get 20 parts. So the first model, what we take is we divide it into 5 parts. We're going to draw 5 lines, 1, 2, 3, 4, and that gives us a grand total of 20 squares. And our other model, which was different, had 10 on either side after we drew our line and split that for a total of 20 rectangles here. Both sides represent the same fraction. This one is going to be 7/10 times 2 is going to be 14/20. You now have 14 out of our 20 total parts. So if we look at how we would write this out on our paper, hopefully you wrote something like the first part, 3/4 plus 7/10 is going to equal a solution which we weren't sure of yet, but because we couldn't add fourths and tenths. Now, once we've changed, we have 15/20 and 14/20, Our denominators are the same. We're talking about the same number of parts in the whole. And we can see that 15 twentieths and 14 twentieths, that's going to give us a total of 29 twentieths. Now, 29 twentieths, we can express as a mixed number as well. 20 twentieths, we know 20 squares or 20 squares here is the same as 1, and that would leave us 9 twentieths left. So if we wanted to take one more step, we've now solved the first problem. We know how many hours he's practiced the piano so far is 1 9 twentieths, or 29 twentieths. We'll use our fraction 29 twentieths when we figure out how many hours he has left to meet his goal. 2 twentieths, or 2 is a whole number. We know we can't subtract 2. We can't subtract our 29 twentieths from 2. So we have to change 2 into a fraction. An equivalent fraction to 2 would be 40 parts of 20. This would be both of our models combined here. This would be 20 parts in this one, 20 parts in this one, for a total of 40 parts out of 20. When we realize that we have 40 twentieths, we want to subtract the 29 twentieths that Carlos has already practiced, then we've solved in our first part of our problem. And we can see that 40 minus 29 is going to leave us with 11 twentieths for how much practicing he still has to do tonight if he wants to reach his goal. So then finally we can write our solution in a sentence. And we'll follow that. We followed our steps here for cubes, and all we have to do is go back to the top. And the first question, how many hours has Carlos practiced piano? Carlos has practiced 1 9 twentieth hours so far. And then the second question, how much longer does he need to practice before going to bed in order to meet his goal? Well, Carlos needs to practice another 11 twentieths hours today. We could have added to meet his goal. But that should hopefully give you a pretty good demonstration on how we're going to solve word problems. And really, all we're doing is breaking them down into our fraction models that we've already worked with before. Okay, let's move on to our next word problem. Another one that you're going to get some time to work on yourself, and then we'll come back and look at the solution. And this problem, Mr. B used 5/8 of a tank of gas on a trip to visit relatives for the weekend, and another 1/2 tank commuting to work. He also used another 1/4 of a tank the following weekend. How many tanks of gas did Mr. B use all together? I'll tell you to take about 10 minutes. Make sure you have everything ready to follow your cubes model for solving. Draw a picture of the model. We want to write the number sentence that expresses your solution. And then I want you to write your answer in a complete sentence somewhere on your sheet as well. All right, we're back, and hopefully your first part of your sheet looks something like this. You should have circled a number of key numbers. In this problem, we had 3. First, he used 5/8 of a tank of gas on a trip to visit relatives for a weekend. He used 1/2 of a tank going back and forth to work. And he used another 1/4 of a tank the following weekend. So we've got 3 key numbers that we've circled, and that should be up on your next sheet as we move to that. You've underlined the question, hopefully. How many tanks of gas did Mr. B use altogether? That's really the only question you have to answer in this one. It's not like we had 2 questions from the last one. We want to box our math action words. So as I went through, I looked and I thought he used 5/8 of a tank, and which is going to be addition to, what is that going to tell us? That's arithmetic. It's going to be plus, addition, and another 1/2 tank commuting to work. Then it said he also used another. So that phrase will tell us we want to add that another 1/4 to what we already had. And so that gave us a total of how many tanks he used all together, which will be a sum, right? So we're going to add our three key numbers. And then when we add those, we'll have our sum, and that'll give us our total. So then when we want to evaluate, we can also look and see that some of the information is maybe a little superfluous, right? We didn't really know that he used the tank of gas on a trip to visit relatives, or that he was commuting to work. All we want to know is how many tanks of gas he used altogether. It doesn't really matter where he was going or on what weekend he used them. All it wants to know in this problem is how much gas he's added altogether. So with our evaluation step complete, we should be able to move on and start working on our area models. I drew my first area model, and I wanted to add my fractions, 5/8 and 1/2 and 1/4. Those were the three key numbers that we came up with in our cubes diagram. And so I used red again to just denote that we're going to add and that we're going to get a sum. Now in our area models, I broke this first model into 8 parts. We had 8 parts, and we needed to shade 5. So we shaded 5, 1, 2, 3, 4, 5. Now we're adding a 1/2 a tank of gas. So our area model gets divided into 2 parts, 1 out of 2. And then we're also going to add a 1/4 of a tank of gas. So we divide this area model into 4 parts, 1, 2, 3, 4. And we shade 1 part there. Well, obviously we don't have the same denominators again, so we're going to have to figure out what to do. Well, we know what we're going to do, right? We have to find some common denominators so that we can add all our partial tanks of gas. And here we go. In our next step, hopefully you did some work that looked like this. The first thing I did was I took this area model for 1/2, and I drew lines that broke it into 8 equal sections. We had 1, 2, 3, 4, 5, 6, 7, 8, and that showed 4 out of 8. 4 out of 8 boxes were shaded, and that was equivalent to 1/2. And then our other model that was in 4 parts, we had to divide that into 8 parts, 1, 2, 3, 4, 5, 6, 7, 8. And 1/4 is 1, 2/8. So we had 2/8. Our next step, and hopefully you did it this way, would be to just add 5 and 4 and 2, and that would give us a total of 11/8. And that's where we get so far. We've got an improper fraction, but we can change that if we want. We can work, I went down to green here, you can follow into green, because 11/8 can be changed to 8/8 plus 3/8. 8/8 is the same as 1, we know that. And that'll leave us with 3/8 left over to add to our 1, which gives us a finishing total of 1 3/8. I hope you did all of that so far. Your paper should look something like this. Your diagrams can be different. Your math can be a little bit different, but the solutions, the key numbers you should come up with are 11/8 and 1 3/8. And then when we get back to our worksheet, we know what the problem was, we followed our model, and we can write our solution in a sentence. Mr. B used 1 3/8 gallons of gas. And that's really all it takes. That was the only question they asked, was how many tanks of gas did Mr. B use all together? So this would be a very acceptable answer. And you showed your work on the other sheet. So that's really all your instructor should be looking for. That's all I'm looking for. Okay, so I've made one last visit back to our template, our word problem solving template, and our cubes explanation. And maybe you want to take a picture or make a copy of notes of these. That's why I've got our little note guy up here. This is going to be real important to help you going forward, solving any types of word problems. You really do need to sum up and circle the key numbers. What do I know? You have to underline the question, what am I being asked? Because a lot of times there's a lot of extra words in there that we learned when we evaluate, right? So we want to know our math action words. Are we going to add, subtract, divide, multiply, or maybe something else? And then finally, we evaluate what steps we take, what information don't I need. There's sometimes a lot of useless information. For example, the one sample we used today, we didn't need to know if they were making chocolate cake or vanilla cake. We just wanted to know how much flour was used. So I'm just going to conclude. I'm going to leave you this slide. I would say this is probably the best place to finish and give you a chance to copy this if you haven't made a copy or taken a picture of it yet. Have a good day, and we'll see you with more word problems next week.